Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll be covering something similar to the last practical tutorial video. This is iodine thiosulfate titrations. So this is iodine, which is some sort of brown solution. So iodine is not very soluble in water, but when it is soluble, it has this brown color. So this is the sodium thiosulfate. It has the S2O32- anion there. So what you have are basically two half equations. The S2O32- go to S4O62-. You could see that in terms of atoms, these are going to be double the amount the one you have on the right hand side. So I put a 2 in front. In doing so, I have a -2 times 2. This gives me a -4 on the left and a -2 on the right. So I need to add 2 more electrons. So what we're saying is the thiosulfate loses electron there. The iodine, on the other hand, will gain electrons to give you the iodide. If you know about your lowest common multiple, if you know about your year 9 redox changes topic, which we already did sometime last year when we were in year 9. So these two on the left and on the right hand side will cancel out as you add these equations and these equations. So the first bit there is your loss of electron. So there's your oxidation. The one on the bottom is your reduction. So reduction is gaining electrons here on the left hand side. So adding them together, you get these redox reactions. Adding them together with the objective of cancelling out the electron is basically lowest common multiple to give you a balanced redox equation. So what we have in this question is that we have seaweed, which you can get in your sushi or your kimbap wrapping. So it contains a commercial, well, it's basically a commercial source of iodine. How much iodine is present in it can be stated in parts per million. So usually when we talk about parts per million, this is a very small amount. So very, very small amount. And then what we say is, if a sample contains 200 ppm, that means there's 200 gram. Is that 1 million? So there's 1 million gram of seaweed. So 200 out of 1 million, if you think about it, there's 200 parts per million. So 200 out of 1 million, 200 parts per million. Okay. So you're provided with an aqueous solution of iodine, which has been obtained from the seaweed. So this one comes from the seaweed. You need to determine the concentration of the iodine. When you get the concentration of the iodine in mole per dm cube, you can get it into gram per dm cube, and you can do comparisons of these masses relative to the mass of the seaweed to get the ppm calculation. So you're going to calculate how much iodine is present in the seaweed by titrating the amount of iodine with sodium thiosulfate. I think this one is just slightly opposite to what the label in the upcoming practical demonstration that I'll show you in the tutorial video. So just keep an eye out for these. The label might have changed, but the idea is still the same. The iodine is still the brown color solution. The sodium thiosulfate is a colorless solution. So here, the sodium thiosulfate goes in the burette, which is the same thing that I did, or I'm going to show you in the upcoming experimental video. Okay. So we're going to pipette out 25.0 cm cube, as that's the pipette size I use, or my students use in the school laboratory. And this P here is basically the aqueous iodine. So inside your conical flask, you're going to have a brown color solution. You keep on adding the thiosulfate from the burette until the red-brown color fades until pale yellow, because you keep on removing the iodine with the thiosulfate until you're very close to the end point that it gets to pale yellow. Very, very dilute amount now. You add Starch Indicator. So in biology, you use iodine to test for starch, and it will give you a blue-black coloration. In chemistry, this is very similar type of reaction. So in the presence of iodine, a little bit of iodine left, which is why you get pale yellow solution. The starch will turn this solution into blue-black, and when all the iodine disappears with one extra drop of thiosulfate, that will remove the entire iodine that is left in the solution. You just get iodide, and these thing here, the sodium salt, are completely soluble. They will be colorless, and that's why it will go from dark blue, and then one extra drop of thiosulfate, it will go entirely colorless. Okay. So the next bit of the tutorial video is actually an experimental video which I've recorded. So yeah, you will see the results I get from this experimental video later. I'm gonna quickly rinse my burette. So by closing the tab at the bottom so that they don't leak, I'm going to roll it around. But remember to always open the tab to allow a bit of distilled water to run through for your washing. And remember, you gotta wash your burette with the solution that you're going to fill it in later on as well. So that's it really on the initial rinsing part. But we know that P, being the iodine, is going to go into the pipette, and Q, which is our thiosulfate, Na2S2O3, sodium thiosulfate, Na plus ions, and S2O3, 2 minus ions. So it's a 2 minus charge ion. I'm just going to quickly rinse my burette before I forget it. So put a little bit in there for rinsing, maybe just a little bit more. So you don't need to fill out the whole burette. So roughly around that much or that much should be alright. Make sure you open the tap so that this bit is rinsed with the solution that you're going to fill it in as well. Before I do that, maybe I'll just roll it around so that I am thoroughly rinsing my burette. Oops, I just remember I haven't opened the tap at the bottom yet and I ran out of my solutions. So open the tap at the bottom. So the bottom is now rinsed with the solution. Throw it out from the top. Open the tap again to remove the washings into the sink. Okay, so now that it's almost dry, but we know that this is the sodium thiosulfate already, so we are reasonably okay. I'm just gonna quickly, fill out my burette. Oops. Avoid filling it in on the floor because you might make the same mistake as me. Okay, so what we need to do is I need to open the tap so that the burette with the solution that I'm filling in right now will fill up the bottom bit as well. So that much is filled already. So I can just put this up here. Okay, so just give me a minute. I just need to go grab a towel. So I made a bit of a mess. My burette is a bit wet at the moment, so I do not want it to, affect my reading or whatever later on. So I'll leave this be for the time being. I have my conical flask, so I just need to rinse it with a little bit of distilled water. By right, you can wash it with tap water and then just rinse it with distilled water. Entirely okay. It's okay to have water left over in the conical flask because whatever you pipette out is going to be an exact amount that's going to go into the conical flask. So it doesn't matter if your conical flask is not dry or it's got some water in it because it will not affect the mole of what you pipette into the conical flask, and therefore it should not affect what you have from your burette tighter. So I haven't rinsed my pipette with the iodine yet. So this is a pipette and this is a pipette filler. So what we're going to do really is I'm just going to suck out a little bit of this. So as I suck out a little bit of this, you can see it is brown in solution. I don't need a lot of it, but I just need to do rinsing. So I'm just, swirling it around. Gotta be careful, I don't want to stain my cloth. Take out the pipette filler and then rinse it like that and you should be alright. So with a little bit of it left in the pipette, it's alright because we're gonna do a pipette suction anyway. So I think the problem is the brown solution is really staining. I don't want it to stain my shirt at all. I should really be careful with this. So I'm ready to suck out 25 cm cube. So this is a 25 ml, 25 cm cube. It's quite brown in color. The instruction with the use of iodine never ever tell you to read from above the meniscus. So we should read below the meniscus. You should be able to read below the meniscus. So this is just above the line. So what I'm going to do is I'm just going to remove a little bit of it. I think that's just alright. Let me just bring a white towel next to you. Hope you can see the line there. There's like a red line. We are reading below the meniscus because the questions in this kind of titration, they never ever tell you to read above the meniscus. It's not a KMNO4. This is a starch indicator for iodine thiosulfate experiment. You read below the meniscus even for this pipette reading when we pipette out the iodine, which is brown in solution. So 25 cm there. Press the button E to eject it into the conical flask. As I mentioned, your conical flask can be a little bit wet with some water. It's alright because whatever you prepare out is an exact mole, exact volume, therefore exact mole of the iodine solution. So it doesn't really matter. Then you got a bit of water, take out your pipette filler. This thing is brown in solution, so you see a little bit of droplet at the end there. You're not going to get everything out, but tapping very gently. 1, 2, 3, 4, 5, 6, 7. You're still going to be left with like one drop at the end. That is taken into account by the level of accuracy of the apparatus. As you could see them, it's a plus minus something. That is alright. So what I'm going to do now is I will suck out the second portion of my 25 cm cube so that I can do my first rough titration and the second exact titration here. So just very quickly, that is 25, oops, no, just very quickly. So avoid parallax error, eye on the eye level as you're reading it. Okay, so that is 25, oops, better get it focused. Not too sure if that's well focused. So right below the meniscus, there's 25 cm cube there. So put it in the conical flask and start pressing E, eject. Let gravity does its job. Okay, let gravity does its job. And you should be alright. So just down to the last couple of drops. 1, 2, 3, 4, 5, 6, 7. You will see I've only prepared 2 conical flasks. That's because I'm going to do one rough titration so that I know roughly where I will stop. And I will do at least 2 exact titrations. But I only have 2 conical flasks, so I'll have to wash out one of my conical flasks and then I'll have to redo it in one of the washed conical flasks. Okay, so let's get started. My initial reading on the Burettes is to 1 decimal place. Reading below the meniscus, there's 1.6 cm cube. Just to convince you, there's 1.6 cm cube. You don't necessarily have to start from 0.0. You can start from anywhere, but of course your teacher might advise you that you might want to start from a number that's easy to count. I have my calculator. I'm an experienced chemist. I don't care where I start because I roughly know where to count it. So that one again is 1. This is a bit tricky. It's now 1.5 cm cube. Maybe it's 1.5 cm cube then. Okay, but this being my first titration, there is my first titration. Rough titration shouldn't matter that much. So 1.5 cm cube. In a titration, you will have a table like this where you have final volume, initial volume. Where we start, we're going to fill in the initial volume. Do not fill in the incorrect bit. Final reading or final volume is basically where you stop. So it's the final minus the initial reading that give you the volume of the title. Everything, the Burettes reading has to be to 1 decimal place for IGCSE, GCSE or all level, the 14 to 16 years old curriculum. Okay. So what I'm going to do is I'm just going to write on a piece of blank paper. So what I have is initial reading or initial volume, and then my initial volume just now was 1.5. My final volume, well, yet to be seen actually. So I have something like this. But of course, in the real exam, you will have the actual question sheet to fill it in. Without further ado, let's get started on the practical. So I've got a white tile at the bottom here. Let me just move my camera around. Okay, I've got a white tile here so that I could see my color change better. I'm doing a rough titration, and they did say that we want to add a starch indicator. So starch is this kind of like cloudy, colorless solution. In the presence of iodine, it will turn the solution blue-black. That's the test for starch in food, in biology. But what we're going to do is we're going to add starch to this substance and it turns blue-black is because this substance contains iodine. We don't add our iodine straight away. We add it when it gets a bit more diluted. When most of the iodine is almost gone, then it goes almost yellow. This is now brown. Okay, so I'm doing a rough titration. I don't really care about where I stop, so I don't slow down at all. I just wait until it gets a bit yellow, then I will add my starch indicator. It's still a bit brown. We must remember to add our indicator because without the indicator we might not see a very sharp end point. So it's getting a bit lighter now. As you can see, it's not as brown as it. Well, actually, it's still pretty brown actually. So let's add a bit more. So this was the original solution, a lot darker. a lot darker. This is just the iodine on its own. This is the one where I've added a bit of thiosulfate already, so some of the iodine has gone to iodide. I would say this is about the region that I would add in the starch. I mean, it depends on you really, but the moment I add in the starch, you should hopefully see it get blue-black. You don't need to add a lot of starch, because just a little bit of starch will give you the blue-black coloration. So it's kind of like a dark coloration. Of course, the more you add, the darker it becomes if I add just a bit more starch. As you know, indicator does not get involved in the reaction. They simply give you a color change here. So even though this is already brown, it gets a bit difficult to tell the end point without the use of the starch indicator. So we should expect it to go, well, colorless, because when all the iodine is gone, there's no iodine, then starch with no iodine would just be colorless. Alright, so let's see what happened here. So my hand on the tab, I don't care where I stop. I open it full speed, and then when it turns colorless, then I stop. Okay, this by far is not an accurate titration because I did not do it drop by drop. If you want accurate, you have to do it drop by drop. I was kind of like going all the way, and then as soon as it changed, then I stopped. This is called rough titration. I'm ready to read my reading now. This one is 21.9 cm cube. If I just bring my white tab here, 21.9 cm cube. Hopefully you can see that better. Let me just move that out a little bit. So 21.9 cm cube. So reading below the meniscus, 21.9 cm cube. So you got 21, 22, so you're reading downwards. So 21.1, 2, 3, blah, blah, blah. Middle point is 21.5. So you got 21.9 below the meniscus there. So this is my rough titrations. I think 21.9, so what was that? 21.9 final volume minus 1.5 initial volume. I get 20.4. This is my title volume. Something like that. So that's my title volume. So this is my rough titration, alright? So I think we're ready to get on with the second titration. So I'm starting from, well, the exact volume where I left off, 21.9. And we know that is acceptable because it was around 20-something. 20-something plus 21 is still going to be 40-something. I still have enough on my Burettes. So I can start from 21.9. A lot of teachers, a lot of instructors would probably advise the student to start from an easy number like 0.0 or 10.0 or 5.0. There's no certain advantage to it, it's just make it easier for you to have a same starting point every single time. But experienced chemists will know that it's all about the volume that matters. So I could add my rough title to my initial volume. So my rough title was 20.4. If I'm starting from 21.9, 21.9 plus 20.4, 21.9 plus 20.4, I get 42.3. So this 42.3 is going to be a rough title. So what I want to do is I want to be careful when I am very close to 42.3, maybe around 40. I'll let it go fast until 40, then I'll do drop by drop just to be safe and get an accurate title with one drop. Okay, so let's get started. So 42.3 would be my rough endpoint. So 40 is where I'll stop down, I'll slow down and do it drop by drop. So 40 is around there. But I might want to add my indicator when it changes brown. I don't really need to swirl that much at this point in time because I'll just be wasting my, my energy. So I just need to let it flow. And then when it's close to, supposed to be 42.3 for the rough title. Rough title means in excess. So I'll just keep on adding until it's pretty close to the end point. Then I'll do it drop by drop. That's the purpose. The purpose of doing a rough titration is so that I know roughly where to stop. As you can see, it is still kind of like yellow with brown. So there's still iodine left in there. So what I'm going to do is I'm going to add my starch indicator. So 2 or 3 drops, and then it goes blue-black. Here now, because I'm right-handed, I am going to swirl with my right, and then I open the tab with my left. I'm very close to the end point. I do not want to close open like that. No sudden movement. Get it drop by drop first. That's the most important thing. Get it drop by drop first. Oops, my bad. Too fast. Okay, that is just right. So I hope you can see the color change there. So that is drop by drop. So my eye doesn't take away from the thing above the white tile. As soon as it changes color, then I stop. I do not care about the volume. I don't read the volume right now. I read the volume at the end point. My left hand doesn't leave the tap. As soon as it changes color, then I will, as soon as it goes, one drop and then colorless, I will stop. That will be my end point. So you need to be very patient at this stage. So just keep on going. So very close now. I think one more drop will do. Just be careful. I shouldn't have stopped. There you go. One drop and it went colorless. Just one extra drop and it went colorless. I shouldn't have stopped just now. I should have let it go all the way drop by drop until it changes, only then when I stop. Okay? Now ready to read the reading of the Burettes. So there's my endpoint, there's my accurate. Endpoint, I knew it was accurate because I did it drop by drop. So, oops, I don't want to zoom in. So that is 41.9 cm cube. You should hopefully see that, 41.9 cm cube. Let me just twist it around. So 41 on top there, 41.9 if you read below the meniscus there. Okay, 41.9 cm cube. So what do I have then? 41.9 for my final title, minus 21.9. This is what my calculator showed me, 41.9 minus 21.9. This is what the calculator will show you. If you write this down as 20, you will have made a mistake because your calculator cannot think on your behalf. It's still a Burette title. It has to be to one decimal place, at least for this 14 to 16 years old, O-level, IGCSE, GCSE curriculum. And if you're doing A-levels, you will have to do this to 2 decimal place. Anyway, let's refill our Burette a little bit with this Thiosulfate colorless solution. So, I don't need a lot of it, just probably around. So I could fill it up to around 21, 22, and then give or take, just now my exact title was around 20, so I will have enough anyway, okay? So I'm just going to quickly wash my conical flask because remember, we can just wash it with this, tap water first. So I'm just going to wash it with tap water, so throw it on the sink. And then I'll quickly rinse it with distilled water. So what happened now is, let's just pipette out what we need. Oops. So doing our second exact title, which is essential. I think I've got a bit of air inside actually. So you don't want air bubbles inside your pipette reading. So let me just get this right and then I'll show you where I am. Oh no. I will say that is alright. Nope, that's not alright. But this one is a bit annoying because it keeps giving me some air bubbles. Okay, so there's 25 mil, 25 cm cube there, just below the meniscus. Hope that convinced you. I've got a bit of water left in there, but it's okay. Remember that a little bit of water will not affect the accurate mole of the substance that we prepared out. And if the mole of the stuff that we prepared out is exactly the same, going to the conical flask, so it will not change the volume of the things in the Burettes, so it doesn't change our title at all with a little bit of distilled water left in the conical flask. Just the last few drops, 1, 2, 3, 4, 5, 6, 7, blah 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 blah. Okay, where do I start? I start from 22.0. So don't have a white tile all the time, but I start from 22.0 cm cube. So give or take 22.0. So my second title should be as exact. Sorry, my third title should be the same as the second because I'm a competent chemist. I'm expecting plus 20. 20 plus that should be 42.0. 42.0 because of the 1 decimal place accuracy of Burettes. So I need to be careful when I reach 41 and do it drop by drop from there, just to be safe. And don't forget to add your starch indicator at the end. So where is 41? Yeah, 41 is here. So 41 is there. We're just gonna zoom in a little bit. So I don't need to, sort or anything because I've done my exact title. I roughly know where they are now. So 41 is where I will stop because that is just before the exact endpoint there. So getting close, getting very, very close. Okay, so it is still a bit yellowy, yellow solution because there's still some iodine left in there. What I'm going to do is I'm just going to add the starch indicator. And here's where I need to be careful and do it drop by drop. So get your drop by drop, really drop by drop. It's going to take practice and time. It will be slow, but you want to be as accurate as possible. So, you don't go full speed. You just swirl gently. Doesn't take much, I think. It is slow, very slow actually. So eyes, do not take your eyes off the conical flask. Don't even bother with the reading because you are doing exact title, so you can read the reading later on when you reach the end point. And don't take your hands off the tab as well. So one hand on the tab and one hand swirling. You don't need to swirl that strong, but one drop will give you the color change. I think the next drop should give me the color change. So pretty sharp, and then I stop straight away. Okay. So now I'm gonna reach my end point. Is 41.0. So, sorry, no, not 41, 42.0, okay? Am I correct, 42.0? Give or take, actually that's 42.1 to be honest. 42.1. Oops, let me just zoom that out. So, I have lost a bit of accuracy, so that's 41, that's 42. So that should be 42.1. You might read as like 42.2, but I read it as 42.1 cm cube just now. So that was 42.1 cm cube. And that is not as exact as we get it to be. That give me 20.1. So what I've gotten is my rough title. My rough title was not drop by drop. It can never be exact. My exact title got to be lesser than the rough title because I did not do this exactly. As you can see, the exact titles, they are pretty accurate to each other. Acceptable margin is plus 0.2 cm cube. This is an error margin. We do not want to have error, 0.2 cm cube difference. We do not want that. We want it to be as exact as possible. In fact, we want zero difference. If we are a competent chemist, we should get them to be as exact as possible. But clearly I'm not very competent, hence I have got a bit of a difference, and we're only human, so we can obviously make mistakes with a little bit of 1 drop or 2 drops, but it should be within the acceptable margin of error, as you would know if you have done enough alternative to practical as well as practical paper. Alright, so I'm back. So you just watched the experimental tutorial video. I did my first titration, which was a rough titration. So that was my initial volume, initial reading, and then 21.9 I got 20.4. This is my rough titration. I make it a habit of always doing a rough titration because if I start wasting my time doing drop by drop from the very first one, then I will never really know around what volume should I slow down and should I start doing drop by drop, because I don't even know where the exact titles are if I don't even redo a rough title. I know I shouldn't take the reading for the rough title at all because it's meant to be in excess. I wasn't being careful. I did not do it drop by drop, and therefore it can never be exact title. Okay, so when I did it exactly, I was careful, so I worked it out 21.9 initial volume plus 20.4. There was in excess still, so I took away a couple of cm cube and I started slowing down. Then, as you saw in the experimental tutorial video, the experimental bit was where I explained my strategy, what I would do as I'm doing it in the lab. I also did a third titration because I needed two exact titration that I have done drop by drop, because I did not do drop by drop for my rough titration because that would just be a waste of time. Okay, so some students, you keep on doing the titration again and again, but in reality you don't have much time in a real examination setting. I knew I could stop here because I was doing this drop by drop. I was super careful. I wasn't that competent, so these are not super exact. Okay, but you're allowed up to this plus minus 0.2 cm cube. This is error margin. You do not want your reading to always be plus minus 0.2. You want your reading to be as exact as possible because you want to have 0 cm cube error margin. But of course, you know, us being humans, us, you know, doing the experiment a couple of times so that we can, you know, overcome this error margin. But sometimes we can't escape it. But I know that within experimental errors, these are within the accepted error margin. As you saw in the tutorial video, experimental bit, I was really careful. I was doing drop by drop. Okay, I already take the best titration results, which never ever include the rough titrations. So using these results, the average volume of Q required, Q was the sodium thiosulfate that was from the burette. I make it a point that I always show my average working. And when I do averaging, so make sure that how many readings are you averaging. Here I'm averaging 2 best titers, so I do them in a bracket, because without the bracket you might mess up keying in a calculator, and when you mess up that bit there will be no turning back for you. My calculator show me 20.05, which is exact value, but then this is not going to be good enough for here because your burette volume throughout in this table, including this difference which your calculator show you 20, but you should write it down to 20.0 because you have to have 1 decimal place for all your burette reading. So this is 20.1 cm cube, including the unit there. And this is to 3 significant figure, or not really 3 sig fig, actually 1 decimal place. There's the usual accuracy for this GCSE, O-level or IGCSE level chemistry, 14 to 16 years old chemistry. You are expected to have this 1 decimal place for burette reading. The volume of solution P, that was your aqueous iodine. That was what we pipette out. That was 25.0 cm cube. As you can see, the accuracy of the pipette, it wasn't just 25 cm cube, it was 25.0 cm cube there. Now Q is our 0.100 mole per dm cube sodium thiosulfate. Remember Na2S2O3 because it's S2O3 2 minus, and then Na plus, you need 2 of that in order to cancel out the charge of 1 of these 2 minus ions. Using your results from A, calculate the concentration of the iodine. So here you want the concentration in mole per dm cube of the iodine. So we got to set up our mole ratio. So I put the iodine on top. So I put down my thiosulfate at the bottom. So from the balance equation, we got to see how many mole of iodine. So from the balance equation, 1 mole of iodine reacts with 2 mole of sodium thiosulfate. 1 iodine, 2 mole of sodium thiosulfate. So from the balance equation, the one on top, iodine here, so 1 mole of iodine reacts with 2 mole of thiosulfate. So it's 1/2 from the balance equation. Now, I'm the type who usually like to put everything in one go. If you're not comfortable with this, you can find the mole of sodium thiosulfate, do the mole ratio, find the mole of iodine, and then get the concentration of iodine from there. I'm doing this method. It's not necessarily the best method for you, but if you can understand it, you can set it up on your own, you are fine. If you cannot, you do it more step by step, all right? So here, this is from the balance equation based on my level. This one on the top here, we know these are solution chemistry. So when you're doing solution chemistry, we talk about N equal to CV. That is your mole of the solution. C refer to concentration. Concentration of the solution in mole per dm cube. That is per dm cube. So actually it's mole over dm cube. We got to multiply by something that will cancel out the dm cube. We got to multiply by the volume in dm cube. And this is the key factor that a lot of students always get it wrong. So you got to remember, 1 dm cube is 1000 cm cube. So you got to convert 1 cm cube into dm cube by dividing by 1000. That one is a given, all right? So here we have the concentration of iodine, which is unknown. The one on top here, N equal to CV. This is the concentration of the iodine in mole per dm cube. I got to multiply by the volume of the iodine in P. So in my titration, the P used was 25.0 cm cube. So we got to convert that cm cube to dm cube. So it's 25.0 over 1000. So that will be mole per dm cube times dm cube, because I converted the cm cube to dm cube by dividing by 1000. At the bottom is my answer from A, because my answer from A was 20.1 cm cube of Q, the thiosulfate. So 20.1 over 1000, that is my dm cube. Now I divide by 1000. I multiply that by the concentration, which is 0.100 mole per dm cube. So having done all that, I'm just going to move this up here. As I'm moving this up here, I don't really move the 2 up there because I want this as my subject. Keep this on the right hand side. So you will see that concentration of iodine multiplied by 25.0 over 1000 equal to a half time 0.100 time 20.1 over 1000. So having done that, you will see that concentration of iodine times that. So I'm going to move all of this down to the bottom here, and I'm running out of space. So what I can do is I'm just going to write a little bit on this for examiner use here. You should try and plan your thing a bit properly, unlike mine. So the concentration of iodine is going to be all of that. So it's a half times 0.100 times 20.1 over 1000. So that thing is on top there. And then the top left here, move the times 25.0 over 1000 all the way to the bottom, because that is just your 25.0 over 1000. So we are doing this in brackets so that we never make any mistake. So you got to know how to key in your calculator, because it's your calculator, okay? So if I do that correctly, I will get 0.0402. This is in mole per dm cube. This happened to be 3 significant figure based on the data given, 1, 2, and 3 significant figure based on the volume of the titer, 1, 2, and 3. These are the volume from the pipette, 1, 2, and 3. So 3 significant figure is entirely reasonable and also appropriate given the precision in the question here. Okay, so I'm just going to move this up a little bit there. Okay. Now using your answer from B, there was a concentration of iodine in P. Calculate the mass of iodine in 1 dm cube of P. Okay, in 1 dm cube of P. So they want the gram per dm cube of I2. The iodine as shown in the question there, I2 in P, that was I2. They never say it's iodine atom. They never trick you in practical paper. They show you everything, because practical is less about theory, but you must know how to read questions, and you must know that iodine exists as a diatomic element, whether it's solid, liquid, or gas there. This is relative atomic. So we know that Mr for I2 is, there are 2 atoms, so it's 127 times 2. So I get 254. This is gram per mole. This means 1 mole of I2 has a mass of 254 gram. I also know that from my formula that gram divided by gram per mole is equal to mole. So if I divide both sides by dm cube, I'm going to get gram per dm cube divided by gram per mole. The bottom doesn't change, but the top bit there changed to gram per dm cube. And this one on the right hand side becomes mole per dm cube here. All I want is the mass per dm cube. So the mass of iodine in 1 dm cube of P is going to be, move up the bottom bit. So move that up. So that's going to be gram per mole. So that is gram per dm cube for iodine. It's going to be the gram per mole, which is the Mr. So 254 multiplied by the mole per dm cube of the iodine, which was the answer from B. So this was mole per dm cube. That was the answer from B. There was a concentration of iodine. Okay, so 0.0402 mole per dm cube there. And the math and the unit, if you follow the unit, it will not disappoint you, and you know that it is sound chemistry as well, because the math is correct there. So 10.2 gram per dm cube to 3 significant figure, because we have decided to be appropriate from the very last bit in the question. We already decided that appropriate number of significant figure based on the data, 3 there, 3 significant figure there, 3 significant figure there. We rounded the previous bit to 3 sig fig. We should round up here to 3 sig fig, appropriate based on the previous data. Okay, so that's 10.2 gram. Okay, because it's 10.2 gram in 1 dm cube, so essentially it's gram per dm cube there. Now the very last bit of this question, if all the iodine present in 1 DNQ of P was obtained from 15,000 grams of seaweed. So what is the amount in ppm of iodine present in the seaweed? So remember the ppm, if you read the question at the very beginning, it was per 1 million, or 1 and then 60 gram of seaweed. Then it is the mass of iodine in gram compared to 1 million gram of seaweed. So what we could say here is, if I have 15,000 gram of seaweed, I have 10.2 gram. Okay, if all the iodine in the 1 dn cube, which means 10.2 gram, comes from 15,000 gram of seaweed. So this is iodine. So my goal is, when there are 1 million gram of seaweed, how many gram of iodine do I have? So that thing divided by 15,000. So just press your calculator there, divided by 15,000, multiply by your answer from the previous bit. So I get 680 ppm. So that final answer there wraps up this question. Okay, so thank you for watching, and I'll see you in the next tutorial video. Don't forget to follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected.